Similar shapes when we got the triangles are side by side. So we've got two triangles, ABC and CDE. They're mathematically similar. We're looking for BD, which is a longer diagonal line going from top right to bottom left. And I've just drawn a line on. So we just want to identify what we're looking for to start with, and then we can go into working out the question. The first step is just to identify the corresponding sides, because these two triangles are not, they don't share the same orientation. So we have to identify the corresponding sides. So if we use colored pens or pencils, that would be an easier way. Highlighters would do it as well. The orange line that I've drawn, those two lengths are corresponding. This length CE is corresponding with AC, and then obviously the base and the top of the shape are corresponding with each other as well. Once we've identified the corresponding sides, we need to find the scale factor, and the only corresponding sides for which we have both lengths are AC and CE, the green one. So we're going to use that to work out the scale factor. So we're going to divide the bigger length by the smaller length, because we want to work out the scale factor from the smaller shape to the bigger shape. So the scale factor is going to be 18 divided by 6. Which is 3, so the bigger shape is 3 times bigger than the smaller shape. They're mathematically similar, so we can use that to work out the missing lengths. We know the scale factor is 3, so now we're going to work out the length CD. So we know we need to work out the length of B to D, but we have to work out the length of C to D before we do that. So C to D is going to be 3 times by 3, because those are the corresponding sides. It's 3 on the smaller shape, therefore on the bigger shape it's 9, because the bigger shape is 3 times as big. So now we know that C to D is 9. We need to work out the entire length of B to D, and B to D is going to be B to C plus C to D, so 3 plus 9, and that's going to be 12 centimeters